This is Coach Schaefer on March 3rd, 2020. Today we'll be taking notes over mean absolute deviation. You can pause this video at any time you want to stop and take notes on your own and catch up at your own pace. So what mean absolute deviation is we are going to take the average or the mean of the set of data. So we have the data. Like I said, we take the average of that data. Then what we do with mean absolute deviation is we're going to then take that average, find the difference from the average between each set of data that we have, and then we find the average of that. So it'll make sense here in a moment. So you have something called the measure of variability. This is the data. It's a data set that we can describe by identifying how spread out the data is. So this is a good way to figure out certain information that might be helpful to us. So for in this case, we're going to be using basketball as an example. Okay, so you have mean. So the first step we do is we find the mean, which means you find the average. Okay, and then what the absolute means is that we take the absolute value. For those of you who might not know what the absolute value is, it means the positive. So if we have a negative number, so if I take 5 minus 7, I'm going to get negative 2. Well, the absolute value of negative 2 would be positive 2. So what absolute value does is it always takes the positive part of the number. Doesn't matter if it's negative or not, we always take only the positive. So the absolute is the absolute value of the difference between the average and the data. And then the last part is deviation. And for deviation, what we do is this is the average of the differences. So we're going to look at two players, LeBron James and James Harden. So the first one is LeBron James. Okay, so we have the points that he scores per game. So we have 29, 24, 22, 34, 29, 18, 16, 33, 57, and 28. Now we have to find the average. Well, how we do that is we take all the numbers, we add them up, we count how many numbers we have, and then we divide that. So what I'm going to do is I'm going to take all the numbers and add them up. Okay, so I have 29 plus 24 plus 22 plus 34 plus 29 plus 18 plus 16 plus 33 plus 57 plus 28. Okay, and then that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of data. So we're going to take that and divide it by 10. And I end up getting 29. So he scores 29 points per game on average. Then for the absolute now is what we do is we find the difference from our average to each data. So the difference between 29 and 29 is 0. From 29 to 24, well, that's a 5-point difference. 29 to 22 is a 7-point difference. 29 to 34 is a 5-point difference. 29 to 29 is 0. 29 to 18 is 11. 29 to 16 is 13. 29 to 33 is 4. 29 to 57 is 28. And 29 to 28 is 1. So then we add these all up together. So now I'm going to take those and add them all together. So we have 0 plus 5 plus 7 plus 5 plus 0 plus 11 plus 13 plus 4 plus 28 plus 1. And that gives me 74. Then we take that, divide it by 10 because we have 10 sets of data, and I get 7.4. So then my deviation is going to be 7.4. So now we're going to look at James Harden. Okay. So now James Harden, he has 27, 27, 29, 22, 27, 27, 22, 29, 31. And then this last one is actually 29. So that's 29 on the last one. So what we're doing is we're going to find the average. So I'm going to take them, add them all together. So I have 27 plus 27 plus 29 plus 22 plus 27 plus 27 plus 22 plus 29 plus 31 plus 29. Take that, we're going to divide it by 10 again, because that's how many sets of data I have, and I get 27 for my average. Then to find the absolute, we take 27, my average, and the difference between each point. So 27, 27, the difference would be 0. 27, 27, difference would be 0. 27 to 29, the difference is 2. 27 to 22, the difference would be 5. 27 to 27 would be 0. 0 again. 27 to 22 is 5. 27 to 29 is 2. 27 to 31 is 4. 27 to the last one, 29, is 2. Then we take those, add them up. So I have 0 plus 0 plus 2 plus 5 plus 0 plus 0 plus 5 plus 2 plus 4 plus 2. Take that, divide it by 10, because that's how many data points I have, and I end up getting 2 as my deviation. So LeBron had a deviation of 7.4. Harden had a deviation of 2. So now, who would you want on your team? Well, we can say LeBron has a higher average. There's no doubt about that. LeBron has the higher average. We know that. LeBron scored 29 points per game. Harden only scored 27. But Harden has a smaller mean absolute deviation, or MAD, which means Harden is more consistent. Now, it doesn't matter whether or not you agree or disagree with that statement. We're just using the data that we have. And from this data, we can state that from these 10 games, Harden had a more consistent average score of 27 than LeBron James. And we can notice that because if we look, we can see that he had a pretty tightly knit group of numbers. There wasn't much difference between them. But if we look here, there's a game where he only scored 18 or 16. There's a game where he scores 57. So we have a larger variation in the data, whereas here we have a smaller variation in the data, which leads to a lower MAD, and this would lead to a higher MAD. So from that, we can say that therefore Harden is a more consistent scorer. Or more consistent, not more consistent scorer, but he more consistently scores this much per game. Alright, now with that, what I want y'all to do is take that, glue it into your notebook. On Google Classroom, I have a quizzes assignment that I would like y'all to complete as well. And I will be taking grades on that. So thank you very much.